Hey, what's going on guys, QEMU here. In this video we're going to be downloading, configuring and building Linux kernel, and then we'll fit a virtual file system in it that would be consistent of the only statically linked binary executable file that will literally be printing something like hello kernel to the screen. It's quite useless in terms of having a working Linux distribution, obviously. However, it's incredibly helpful in getting started with the entire building Linux from scratch. And before we start, just a few words like who is this video intended for. So if you haven't used Linux before, then you definitely need to get started with some an existing Linux distributions to get used to the environment, because, well, for me personally it took around 5 years to get used to it. So yeah, it's kind of like not that trivial really. And definitely if you're on Windows and want to switch to Linux, or at least try it, then this is not the way to go. First of all, because all the build that I'm going to be considering here is going to be done under Linux itself, because it's the simplest possible way of doing things. Because otherwise, if you're doing this from Windows, you need cross-compiling, which adds a ton of complexity to the process, which is not easy itself. So yeah, doing compiling, like building Linux under Linux, is much easier in terms of you don't need to you don't need to deal with the cross compilation at all. And on the other hand, if you're a Linux user, experienced or not really, but you really want to learn how the system works from the very basics, from the very roots, from bottom to top basically. In this case, this video might be helpful. So I'm planning a series actually. I'm not sure how far it goes. I just tried a few very first steps to consider, and it goes quite interestingly. But the main problem is that there is a whole lot of resources on the internet how to build your own Linux system from scratch, and the problem is that you're trying to get into one little piece and then it branches exponentially, and you're just getting absolutely overwhelmed without having any idea where to proceed, because you're getting stuck, like putting lots of new things into your head, and it's just the mind just explodes, and it's not really that simple to find the proper path. So one of the main reasons why I decided to consider this series is actually to offer the path of researching this process of building Linux from scratch, in order to have a modular understanding, like this part, and so on. So every part can be observed as a big black box. It will get more clear when it comes to actual installation. But anyways, I really hope that this would serve as a sort of a foundation, like where to kickstart from. And it's really important to have a general kind of overall understanding, which is not really that easy to get, because the internet offers us lots of like ready-made solutions, like you just do this, and this, and you'll get that. But how did you get that? You have no idea. And even like what the major core parts that you're going to be working with might also not always be that clear what they are. So hopefully this video will clarify the process a little bit. I'm not a pro at any point. I'm doing this, like I started doing this like a couple of days ago. So if you're a noob like me, then hopefully this is going to be even more helpful for you, because it's just not really how to install Linux, but how not to get overwhelmed by installing Linux, something like that. So if you're a pro in this, and if you notice some major mistakes in what am I doing, then I encourage you to write some commentaries, like pointing out the mistakes, because I'm learning myself and I'm very interested in this. And again, like, if I'm doing something horribly wrong, please kindly let me know, because I'm pretty new to this as well. So without further ado, let's actually start. We could have download and unzip using the commands within the terminal emulator. But I will try to make things visually as much as I can, just not to overwhelm you from the very first it's not second of the video, the first 5 minutes apparently. But anyway, so I'm just downloading the latest release, and here it goes. And if I just show this in folder, it goes to my downloads folder, and I just copy this, and here is the working folder. So I call it So CMK Linux tutorial. So here I just want to paste it. And now I just want to extract here. Now it's extracting. So we just downloaded the latest kernel source code. It's not a build. We're going to be making the build on our own. By the time it's extracting, here I have a little cheat sheet that is going to be helpful. So the steps I just considered can be done like this. You can just get this via the widget and put the link. Then unzip with the command. Then you need to cd to go to the directory that you've just downloaded. Well, actually, you have the Linux 5.18.10, while the extracting one is 5.18.11. Because this was yesterday, this is today, so it's updating really quickly. Yeah. By the time it's updating, we can install the dependencies that are needed to build the sources. And again, like this list doesn't ensure the fact that if you install all of these guys, that it would definitely be working for you. But most of the most essential things are being included here. Well, actually, I had all of this instead of libelf, I believe. But it's not even. It's interestingly, where's the libelf? Yeah, libelf dev. So I had everything but the libelf dev being installed on my Linux Mint system. But I've been installing binutils and lots of things before for my work. So anyways, you can just grab this entire line and copy, and you just make sure that we did everything. So hopefully it did unzip. Okay, so probably don't need this anymore. Go into this, go in here. Okay, and open terminal here. So it's like we just did the cd to the Linux folder. Okay, but before that, just installing all the dependencies. So sudo apt-get install and all of this stuff. Obviously, I'll already have that being installed. Just tells that everything has been installed already so far. Okay, so now we're ready to configure and actually build. So if you type make help here, assuming that you are in this newly downloaded Linux folder, then there is a whole lot of things that is offered for you. But what we need, we're going for the simplest build possible, the default settings, because changing something in the kernel might end up it's not going to be working on some target hardware. It just might be buggy and you have no idea why. And so if you don't know what you're doing, it's really better to stick to the default configuration. And there is a default for x86-64 def config, which is the build for the generic build for x86 and x86-64 for 64-bit platforms. So otherwise, you can build for this i386 platforms. Or if you want just for 32-bit platforms, there is another way just to get rid of that flag for compiling the 64-bit kernel, which I'll demonstrate just right in a moment. So this is what we need. Copy. And if I just say make in this config, then it starts its configuration. I'm not sure. Bearing in mind this .o files would probably compile something, but it doesn't matter really. So from now, the configuration file, this .config, is actually available there. If we can probably even see that. So it's really a whole lot of settings that just being set or not set, like set to yes or set to no. So that's the default. That's the default configuration. However, if you want to, if you're smart, unlikely I am, I'm not, you can do this make in menu config. That will bring you into the incursive based interface where you can go for some custom setups. So for instance, like device drivers, you want to add something or to remove something, double escape to escape, or file systems, say you want to add something else that is not here or whatever. I don't recommend doing this. So, just wanted to show you. The only thing you might be interested here is the 64-bit kernel. So if you just if you just make like this, probably should build the 32-bit kernel. Actually, I didn't try this, but yeah, it seems to be quite reasonable. But yeah, we're not going to be doing this, and I just exit. Do you wish to save the new configuration? No, I don't. And from now on, we are ready to actually start making this. Now, here is the command to speed up make a little bit. So you could just say make, but this -j stays for jobs, and this base just calculates somehow the optimal number of I'm not sure whether it's threads or something, but or how many jobs. Yeah, literally how many jobs is about to be considering. So this just speeds up the making process. If you just type make, it's going to be slower. If you do it like this, it's just going to be faster. So now I just paste this in and hit enter. And now on my computer, on my laptop, it takes around somewhere around half an hour to build the entire thing. So it's quite long. And well, obviously the video is not going to be lasting that long. At least we're not going to be watching how the compiler works. It just compiles, and that's good. By the time it works, we need to do another one little thing. And then when we get done with that little thing, I just pause the video, and then when it compiles, I get back to you, but you won't really see this. Okay, so just don't need this for a while. I just can open a new tab here. So I want a new tab here. No, not here. So now let's assume that we already have the kernel been built. So now in order to make a boot, if we don't provide the so-called virtual file system, that it's not gonna boot. It just gives you an error that a virtual file system is not found. So and within that virtual file system, we need sort of a kernel entry point, which is known as init. So there should be a binary called init, or otherwise you can specify the kernel parameters like init equals, for instance, like bin shell, to make the shell as the init for a kernel if you're running this in QEMU. But anyways, now we'll just write a simple hello world program. So let's pick up the proper kind of direction for this. So here in the Linux folder, I just want to create a new folder. Let's call this VFS, which stands for Virtual File System. And here in the Virtual File System, I want to create a new file, and let's call it hello kernel.c. And here, say include stdio.h, and then I want to provide the main function. Sorry for not providing this this argc, argv stuff. So I just want to say printf hello kernel and new line. And now I want to sleep for a long time, because if this program exists, then the kernel will panic. Panic means like something goes wrong in the kernel and it will stop working. So the initial of this init program is meant never to stop until the system is working. Well, maybe not that precise in explaining that. By the way, I'll give you an absolutely fantastic link in the description below this video, where a really experienced guy is actually explaining much better than I do. That video takes around 2 hours, and that's incredibly insightful. At least for me, I was watching that, like I was charmed after. Okay, so this just makes sure that the program can run for quite a bit of time. Now we need to compile it. So here's a little trick. So if I just open the terminal here, I'm using the GCC obviously, so GCC, and I need to make it static because we don't have the libc, this dynamic library to bring all together. So this is going to be the static binary. So minus static hello kernel.c -o, and we call it init. Okay, here we go. Just gives a warning, but it doesn't matter that much really. It's still gonna be working. So we got this init here. And now we need to turn this single binary executable file into sort of a file system. So I don't remember this command by heart, but here it is. So one of the format that is understood by the kernel is the cpiojz. Not exactly sure what this thing does, but actually this line creates the file system from where you are. So let's say here, if I just paste things, then it just creates this root cpiojz. So I could just create it here, and now this init, and probably this kernel as well. And if you have some folders here, it would also add those. But we don't care about that at the moment. So it's enough to know that this root cpio.jz is something that we're gonna be passing as an argument to the QEMU system x86-64 as the init rd. And even though init rd is a little bit outdated, and now they use like some like ramafast. I don't remember. I don't want to talk about things that I don't want to say I don't quite understand, but I don't quite understand the great details about that. And again, like the video that I'll give you a link in the description below explains that in much greater details. So here we'll need to specify the path to the actual file system, to the actual virtual file system. So well, by the time it's compiling, we can actually, since we don't probably need this any longer, I just need to alter this a little bit. So arc x86 would be that image is the compressed image of the compiled kernel, which is not yet ready, but it would be. And then this init rd, so it's not arc, it's directly, it goes to VFS, goes to virtual file system, and then this root cpiojz. And then if kernel panics, then we just exit, and we're gonna be talking to the kernel why the tty-s0 console. And is that it? Yes, and we don't want the graphic mode, so we're gonna be run this in the Linux terminal, and no reboot, which means that if it wants to reboot, it just escapes from. It just like the program terminates. Okay, now I just paused the video because it takes another, I don't know, 25 minutes probably to get done with the compilation, and once it's done, I'll get back to you. Okay, so finally we got our Linux kernel being compiled, and if you're wondering how long did it take, you just see the time here, and just a moment ago in the video back, before I paused the recording, to get an idea how long does it take on my machine to get compiled. But anyways, from now on we can already run this in the QEMU. But before we do this, just another idea of this bz image. So if you go to arc x86 boot, then here you will have this bz image somewhere. As probably it's not seen in this browser, so let me just see it here better. So arc x86 boot, and it should be here. Let me search bz image. And indeed it is. So it's 10 megabytes. So our kernel now consists, like, takes 10 megabytes. And again, like, this is the default configuration, so it can be much smaller. It can be under 1 megabyte if you get rid of the whole lot of things that you don't need. But I think that 10 megabytes for a kernel is not that big, really. So now this command, the QEMU system x86-64 no graphic no reboot kernel. So kernel points to this exact file. And now the virtual file system actually points to here, virtual file system root cpiojz. And then, yeah, this appends. So if I now copy this command to start the QEMU emulator. Yeah, by the way, if you don't have QEMU being installed, you just go install it. So just paste this in, hit enter, hold my breath, and hope for the best. So yeah, the kernel is booting, and yeah, and we got this hello kernel, which proves the concept that the file system, the virtual file system, has been linked. I even tried to do somewhere with the mouse driver. It's quite interestingly. But anyways, we got this program working here, which is absolutely fantastic. So at this point we can stop, and the next video we'll try to do the same, but we'll replace this tiny little binary executable that we make, this hello kernel, with a thing called busybox. But this is gonna be the topic of completely different video, so it's gonna be in the next video. And that busybox would allow us to deal with most common Linux commands that you get used to, and also provide that operating system like environment that you are get used to as well as a Linux user. This is it from my side, guys. Thanks for watching. See you in the next video. Until then, and take care.